A very good morning. Can you hear me?
Yes, sir.
Okay. So today we will start module 2, training models. So far we have discussed basic learning concepts in machine learning. Now we slowly get into the machine learning training, right? So the first module covers various types of learnings, followed by finders algorithm, then followed by your candidate elimination, then your decision tree, then your random forest and ensemble methods. So here in module 1, there is a chances of getting 3 questions. I mean, past probability of questions in from first module is you have probability of 3 questions. One is finders algorithm, candidate elimination, and decision trees. Okay. So in the module 2, similarly, we have here we are going to discuss 4 main topics. In the theory class is concerned, I'll teach you the concept. In lab we will execute the programs in Python. Okay. So anyway, in simple programs I'll be explaining in the class, uh, uh, but the main implementation we will do it in the lab, either using any tool, Colab or any other Jupyter or whatever it may be. uh, let's see. Okay. So anyway, I have all the lab experiments ready. Let's see. So now the topic is the module 2 talks about complete training models. When you say training models, so obviously your data set playing a vital role in it, right? So that will act as your input. So we will give the input as a data set to the machine. So machine will start training the models. Then finally we will do something what out in terms of output, that we are going to predict something. That is what the training, right? Always through these training models or through these machines, what we are going to expect some kind of predictions, some kind of classification, some kind of future trends, right? That is the purpose of these machines. Instead of what human we are not able to do it, the machine will do it by using past data. This is, machine also does not do anything which is new, but we are giving the data, we are giving the data set, we are giving defining the past activities. So from that it will do predictions. So module 1, when you say machine learning, we have two types. One is your classification, sorry, supervised and unsupervised. Under supervised you have classification and regression. In classification, one of the main problem we have discussed in the module 1 is decision trees, right? So decision tree is one of the concept where we will use most frequently. So now let us move on to the another concept called regression. So these are all comes under supervised learning techniques. The module 1 and 2 completely covers under supervised learning techniques. So under the classification technique, we have discussed decision tree. Now for regression, we will discuss your linear regression, your logistic regression, and polynomial regression. Then followed by one more supervision technique is KNN, right? K nearest neighbor learning. So these 4 topics we will learn in the module 2. Okay. So now let us move on to the introduction. I think I want to keep you little aware of the same again, the basic concept. So I kept the same slides. So when you give the data, either in terms of labeled data, unlabeled data, the machine learning trainer, meaning a machine, will read such data as an input, and it will give the same data sets to the model. Then the model will give you the output, right? So after predicting this machine learning, when you give a program, when you give a data, or when you give a set of rules to a program, in traditional programming it will give you as output. But whereas when you give, because why we are giving output here, before giving output, that is already trained. So we are giving such pre-processed all other data, right? So cleaned data after removing all missing values, everything. When you give the data output to the machine learning, here there is output of this machine learning trainers we are giving to the model. Then machine learning will do modeling. So then after that we will get some kind of output. This such outputs we used to call inferences or predictions, right? So now this is your nothing but your outcome. So this outcome is completely future prediction based. So that is what the machine learning is all about. Whereas in normal programming, we will get the output and after execution. Here we will get the prediction or inferences or some kind of patterns or rules or models, whatever it may be. So that is the outcome of your machine learning domain. What do you mean with this training model? Training model is nothing but a data set that is used to train an ML algorithm. So how this training algorithm, training model will work? Training model is generally used to run through the input. Obviously, the model will always run through the input, though through the algorithm. There will be some kind of machine learning algorithm may be there in order to correlate the process the output against the sample output, right? So this is how your training model is nothing but just you're executing ML algorithm with the help of your input. Input is nothing but a data set. So this same process will be iterated. This such iterative process we used to call model fitting, right? So until we get the best fit, so the training model will be trained continuously. That is what this model fitting is all about. So there are several types of machine learning models, as you know. So supervised and unsupervised. So when I say supervised, here we used to have classification technique. When you say it is sorry, when you say there is a if the discrete data is involved, then you can go with the classification technique. If continuous data is involved, we'll go with regression techniques, right? So that is what this supervised algorithm is all about. When I say data includes your features and the labels. So label, when you say label, when you categorize the label, it contains supervised learning, then unsupervised learnings. So now, as you know already, that when you say labeled data, this each data set has some labels, right? So like this sepal length, this iris data set, sepal length, sepal width, pedal length, and pedal width, species. So these are all kind of labels. These values are, these are the your new the I mean, what do you call, this value 5.1, 4.9, all these floating values are under the sepal length. Again, the sepal width and pedal width, these are all comes under different column names, right? So that is your labeling. So these data 4.7, 4.9 is identified with the help of sepal length. So that is what labeled data. So species your categorical data. So whereas you can see this dog image is loaded. So now this image is nothing but has a label called dog. Now if I want to do classification or clustering, I want to group how many dogs are there in this label images or data set. Then you can calculate. We'll give the countings to 1, 2, 3, 4. Suppose here there are no labels, then what we will do? So that is what your unlabeled data. So now here the image is not, we are unable to identify this image with either with the help of any one of the feature or any one of the data or any other data labels. So such things we used to call unlabeled data. So now how we will do prediction? Based on the observations, we will do predictions here. So that is what labeled data and unlabeled data. Now again let us go back to the new topic. So supervised, unsupervised and semi-supervised. In semi-supervised, supervised we will use only labeled data, algorithms for classification and regression. So now we are going to discuss about completely regression, because since it is your module 2. So for classification example, we have discussed decision trees. Okay. Unsupervised, we will use unlabeled data. So here the algorithms are classification and clustering and the association, right? Semi-supervised, both unlabeled data and labeled data might be used, but here the algorithm what we will use, GAN is your best semi-supervised algorithm. The same thing. So here the supervised learning deals with the labeled data set. So unsupervised, unlabeled data set, semi-supervised, hybrid learning, both supervised and unsupervised. Whereas reinforcement learning, here there are no training of data sets is required, because this is a learning through the agents, learning through the from the environments. So here there is no training data is required, right? It's here we are based on the past feedback system, we are training the machines. So now these are some popular learning algorithms, supervised classification learning algorithms: linear regression, logistic regression, polynomial regression, decision tree, SVM, naive Bayes, KNN. K means random forest. So K means it won't come here. K means is a clustering algorithm, so it won't come here. So KNN, random forest neural network. So these all comes under your supervised learning techniques. Okay. So what is the difference between training data and test data? Training data, as you know, it is given to raw data. Raw data is generally we used to call training data, so which is used to learn the machine, so, right? So once the learning is done, then when you need a data for testing, no, such a testing data we used to call your test data. So how the machine before learning, whatever data you use is training data. After learning, so whatever that we use for testing data, that's what training data and testing data. So then a supervised algorithm, as we know, same, it is used the once the set of, with the help of a set of training data or labeled data, we will train our models. Once our model has been trained, we can use it to predict the results, right? So that is what this supervised learning algorithm. So generally, in one word, we can say this supervised learning algorithm learns from the known data set. That is training data. So which has a labels to make predictions. So this is what we will do now here. So with the help of uh, labeling, we will predict the data. So that is what supervised learning. So without, if there is no label, then there won't be any prediction, then that will goes under unsupervised. Here there are two types, one is a classification and regression, right? So such classifications we have studied. Now we'll move on to the regression. So what is a regression? Regression is simple meanings a prediction, nothing else, right? So whatever the projects you do now, generally students they'll come with kind of predictions, right? So starting from the rainfall prediction, salary prediction, rent prediction, right? So everything. So that is share market prediction. So these all generally comes under a type of regressions, right? So these regressions are commonly used in the machine learning field to predict continuous value, right? Regression task can predict the value of a dependent variable based on a set of independent variable, also called predictors or regressors. So I'll be showing you. So here an example. So for example, wait. Y is equal to, so suppose this is mx plus c, okay? So now this x is nothing but your independent variable, whereas y is nothing but your dependent variable, because whenever this x value changes, then the y value also changes. So this y is a dependent variable, x is an independent variable, right? So that is what this, so this is completely depends on this statement, right? So that is what this regression is all about. So generally regression is where does it come from? Where it is come from the your statistical modeling. Since the machine learning is much newer concept, it has adopted regression analysis. So also the regression is ordered, at the same time it is continuous. The output consists of one or more continuous variables. There are many different types of regression. One of the most common used is linear regression, right? Because this is the easy to understand. At the same time, we will get the maximum efficiency. So here also this linear regression main thing is it does not require any tuning parameters. You no need to change or alter any parameters. So it has come with by default. So generally what we will do with this linear regression, there are two types of regression. One is a linear regression, another one is a logistic regression, third one is a polynomial regression. So in linear regression, what we will do, we will identify we will find out we will establish the relationship between two variable. What is the relationship between x and y? That is what your linear regression and the logistic regression is equal to. Suppose y is equal to mx plus c. Suppose if x value is changing, x power 1, x power 2, x power 3, x power 4, x power 5. So what it is, does it mean? So because of this y is dependent on x, so this value to entire value get changed. So suppose if this x value is 1, right? So y is equal to mx plus c. So x to the power is 1, then you can say that is a linear regression. Suppose x to the power 2, 2 squared, 4 squared, 6 squared, 8 squared, then when this case mx power 1 is nothing but linear, so that is straight line. Suppose x squared, 2 squared, 2 power 3, 2 power 4, then that will become your logistic regression. Then your line become your curve, not the straight line, right? So that is what the difference between your linear and logistic. Linear always your independent power, the independent exponential parameter is 1, then that is linear. If it is not equal to 1, then other than 1, then we can say it is your logistic regression, sorry, other than linear regressions, right? So now, so this independent variable column, we will keep it in x-axis. So this dependency, that is y. That is why we kept x is nothing but independent, y is nothing but your dependent variable. X-axis in terms of independent, this is y-axis is dependent. Now I am trying to establish the mark the points, your discrete points here, here and there, here and there. So now my line is crossing via these points, right? So now we can see this is the range. So I told you this is error range. We used to call this is error. Some discrete values are here and there is present, but there are some difference. There are some range difference. Meaning suppose this may be your 4, this may be your 4.5. So this may be your 3.5. This may be your 3. So the difference is the range is very less. So that is what we used to call this is this range. If it is more or less error, more variance, then you can say overfitting, right? Suppose if it is more error and less variance, then we will use to say underfitting, right? So that is what this regression is all about. Linear regression and non-linear. Linear meaning if the dependent variable power is 1, then you can say linear. If a power is other than 1, then you can say it is logistic. So that is what we used to call x is a predictor variable, y is your response variable. Suppose the non-linear relationship where the exponent of any variable is not equal to 1, then generally that will create the curve. So when the curve, if it is your output is a curve, then that is not linear, that is your logistic. So this may be like this or it may be like this, something like this, right? So that is what predictor and response variables. What is the advantages of your linear regression? So linear regression is generally easy to understand and highly interpretable. So we can easily predict what would be the next, right? So linear regression does have its drawback, though for instance it has very variability on predictive accuracy depending on the trends in the data. So generally this regression we used to call is a continuous one. By default it is a continuous one. Cons of linear regression. So regression can be used to predict the future trends based on the previous data. Suppose if there is any misplaced data or if any missing values in the past data, then the entire prediction will go wrong. That is one of the disadvantage. Suppose if the data shows parabolic trend, then the linear regression will always produce very accurate results. If the data shows parabolic trend, then the linear regression will not produce any accuracy results. Yes. When compared to the parabolic regression, because as the name implies, linear regression presumes that the data is linear. Yes. Regression falls under the supervised learning section and produces continuous outputs rather than the discrete outputs like KNN might produce. Regression is not always linear. That is what regression is not always linear. During linear time, it is linear straight line. Sometimes it may be a curve, right? In polynomial regression, so that will be a curve. Even logistic, it will be a curve. So if the data is your discrete, then you will get the representation like a scatter plot like this. If it is a continuous, you will get like this. So when you say discrete data can only take on certain individual values, right? Book number of the pages in a book is a discrete variable. Page number 17, that is a discrete, very fixed. My shoe size is 7 inch. My shoe size is 8. But you cannot say not in between. So that is not a discrete value. Discrete value is meaning it is like a static value, fixed value. Number of people in the race, 7. Number of days in a week, 7. Number of months in a year, 12. So that is a fixed value. That is what your discrete is all about. Continuous value, meaning continuous data can take any value in a certain range. Length of the movie, 2 hours 45 minutes, something like that, or 2 hours 39 minutes, something like that. Is a continuous variable. Temperature is a continuous variable. Time taken to run the race is a continuous variable. So that will change time to time, right? So that is what your continuous is all about. Where is this linear regression used? Generally, there are different applications. The main is it is used in business to evaluate the trends and make the estimates for their forecasts. So that is one of the main trend in evaluating the trends and sales estimates. Second one is, so the linear regression is used to analyze the effects of the pricing on consumer behavior. So nothing but your sales forecast. If a company changes the price on certain products several times, it can record the quantity it sells for each price level and then performs the linear regression with the quantity sold as the dependent variable and the price as explanatory variable. The results would be a line that predicts the extent to which consumer reduces their consumption of the product, prices increase. So this is generally your like a stock price exchange or share market exchange. So generally it is used to predict the price values. What is the today's gold rate? What is the today's Bitcoin rate? What is that? So that is completely, it is a kind of predictions, rainfall prediction, satellite prediction, everything, flood prediction, complete prediction. So here one of the best example is your price prediction. Also it is your regression example. Assessing the risk. In order of assessing the risk, your health insurance company, there your regression is used. That is what your linear regression is all about. Then your logistic regression. Logistic regression is nothing but this algorithm predicts the discrete value either in terms of binary value 0 or 1 or yes or no or true or false, right? For the set of independent variables that have been passed to it. It does the prediction by mapping the unseen data to the logist function that has been programmed into it. The algorithm predicts the probability of new data and so it is output lies between zeros and ones. So that is what your logistic regression. You can see here your linear is always a straight line. So your logistic is always vary from 0 to 1. So the y always varies within the range of 0 to 1. That is what the curve looks like this. So that is what your logistic regression. So how do you evaluate the ML models? There are different parameters was there, as you know that slowly you will study. Accuracy, precision, recall sensitivity, specificity, F1 score. So these are some parameters is used to evaluate the model. One is accuracy. Accuracy with the what? What is the purpose of accuracy? Accuracy generally tells you the overall performance of the model. Generally, whatever the model you develop, first we will calculate the accuracy. Accuracy is used to calculate the evaluate the overall performance of the model. So TP plus TN divided by TP plus TN plus FP plus FN. True positive divided plus true negative divided by true positive plus true negative plus false positive plus false negative. So when you do this, you will get this overall performance. Precision is nothing but how accurate the positive predictions are. True positive divided by true positive plus false positive. So recall sensitivity is nothing but true positive divided by true positive plus false negative. Specificity is nothing but it calculates the actual negative sample. So true negative divided by true negative plus FB. F1 score is nothing but is used to hybrid the model for unbalanced classes. 2 into TP divided by 2 into TP plus FP plus FN. So this is your ML performance matrix. Okay. So this is how your regression analysis is used. So you can see the difference in terms of core concept. Linear regression is the data is modeled using a straight line, but whereas in a logistic regression here the data is modeled using sigmoid. Sigmoid is nothing but like a curve. So linear regression is used with continuous values. Logistic regression is used with categorical values. The output or prediction is value of the variable. Here logistic regression probability of the occurrence. Accuracy and goodness of the fit is measured by loss R squared adjusted R squareds. But whereas here measured by accuracy, precision, recall, F1 score, ROC curve and the confusion matrix. These are all some of the evaluation matrix. So finally, linear and logistic. So what is the application of overall supervised learning? So applications of supervised learning, it may be used in various fields. One is bioinformatics, then speech recognition, your spam detection, then object recognition for vision, email spam classification, bank customers loan pay willingness prediction, cancer tumor cell identification, sentiment analysis, drug classification, facial key point detection and pedestrian detection in automatic car parking. So these are all you can see that read the title, you can feel that is these are all kind of predictions, right? So what type of based on the parameters divided overall conclusion data set is here we will use labeled data and unsupervised we will use unlabeled data. Method of learning is here we will use guided learning, there we will use your learns by self learning. Complexity self learning and complex, so accuracy is more accurate, less unsupervised learning is less accurate because of unlabeling. Disadvantages of supervised learning, you could overfit your algorithm easily. Good examples needs to be used to train the model. Computation time is very large for supervised learning. Unwanted data could reduce the accuracy. Pre-processing of data is always challenge. If the data is incorrect, you make your algorithm learn incorrectly. So some of the few basic machine learning project ideas, we will divide it into three categories: easy, mid and pro. Easy, there are some kind of classification and predictions like iris flower classification, loan prediction, stock prediction, fake news detection. So these are basic ECR level projects. In mid level, we will go music genre classification, Bitcoin prediction, customer recognition, sign language recognition, right? Higher level proficiency levels, sentiment analysis, catching illegal phishing projects, speech emotion recognition, and image segmentation. So these are high level projects. So these are some data science LinkedIn pages as you can follow in order to get the current updates that I used to follow always. So Machine Learning India, ML India, which is in LinkedIn. Machine Learning Mastery is also one of the famous page in LinkedIn. Data Science Central, Towards AI, and Data Science Dojo. So these are the official 5 data science websites. You can watch it in order to get more ideas. So this is your data science ecosystem. So before using all these algorithm, you can have a look at it. So machine learning, when you say machine learning, different types. Deploy, you can use AWS, Azure, GCP. Data visualization, you can use Tableau, Power BI, MATLAB, ggplot, Seaborn. For analysis, you can use feature engineering, data wrangling, EDA. Web scraping, you can use beautiful Scrappy, URL. Programming languages, this can be implemented with Python or Java. IDE, we can use anything: Python, Jupyter, Colab, and Spider, and R Studio. So these are all is just an idea. So you can collaborate with anything, right? So this is simple link. So you can go to towardsdatascience.com where I used to follow maximum. So here there's just a link I found. So how to train a machine learning model in 5 minutes. So if you type this, you'll get this link. So how to train a machine learning model in 5 minutes link. This is what your also you can found this Amazon AWS Google Docs, AWS Docs. It talks about machine learning training models, so that is also very interesting. So this is next one is this we will explain you in the next class for coding, right? So next class we will take one linear regression in machine learning. We will try this on one program, sample program, and we'll try this tomorrow. So this is how the basic idea about your linear regression, logistic regression. The next class I will be same. The idea I think you have understood now. So linear regression I will take one example. I will run the code in Colab. Again I will take logistic regression. I will run the code in Colab. Similarly polynomial and KNN. Okay. So that's all from today. So how many of you attended the quiz? So let me check your quiz answers. So 53 out of 78. The first score is, let me check the score. Shall I release the result? This one. Summary of the result. Hmm. 54 responses, average score is 42. Let me release the score. Do you want to know the answers for those questions?
Yes, sir.
Yeah. We will review the answers so that you will get to know. So what is it true about machine learning? So machine learning true about the machine learning. All the points are true about the machine learning. It is a field of computer science, a type of AI. It focuses on allow the computer to learn from experience. So answer is all the above. Second question, ML is a field of AI, consists of learning algorithm. Is that all the above? So main purpose of ML is the same, improve performance, executing some task over time with experience. Different learning methods do not include, generally it will include memorization, analogy and deduction, but it does not include any introduction. So that is right here. Which of the following is a widely used and effective machine learning algorithm based on idea of bagging? So we have discussed under ensemble, there are four methods: bagging, boosting, right, stacking. So now bagging is used in random forest generally, the idea, because the averaging, we will take averaging or weighted averaging or max vote kind of techniques. High entropy means that the partition and classifications are not pure. So right. So that is we already discussed in the class. Machine learning problems involves four attributes plus the class plus a class. The attributes have 3, 2, 2, 2 possible values. Each the class has 3 possible values. How many maximum possible in different class? So it is 72. 3 into 2 into 2 into 2. So totally you will have 72 values. So 72 is the answer. How do you handle the missing or corrupted data in the data set? So obviously all the above. Either you can drop the missing row or replace the missing values with mean, mode, medium, or else assign unique category value, or else assign 0. So all the above are the answers. Which of the following is a disadvantage of decision tree? Decision tree is prone to be overfit. That is your disadvantage of decision tree. In general, to have well-defined learning problem, we must identify which of the tasks. So this all everything you need to identify all the things, all the above. The concept learning inferred dash valued boolean valued function. Generally, yes, it's a true or false only. So that is a concept learning. What kind of learning algorithm for facial identities or facial expressions? Generally, from that, what we will extract recognition the patterns. So that is second one. Then real-time decision, game AI, learning tasks, skill acquisition, robot navy. These are application reinforcement learning. Very good. So targeted marketing, recommendation system, customer segmentations are application of unsupervised learning. Right, so all the movie recommendation system, all other recommendation system under the unsupervised learning. Fraud detection, image classification, mail classification, these all comes under classifications, image supervised learning. Finders algorithm, it will work only for positives, no positive hypothesis, as you remember. So, but how come both? So, your candidate elimination will work for both, but finders algorithm, so one more work for positive hypothesis. Candidate elimination algorithm is represented with version spacing. Inductive learning is based on knowledge, and yes, it is true. Drawbacks of the finders algorithm is that it assumes the consistency within the training set. Yes, it will assume the consistency only for positive hypothesis. That is why it is true. So what strategies can help in reduce overfitting the decision tree? So that is your 1, 2, 3 are the overfitting reasons: maximum depth, number of samples, and pruning. Which of the following ensemble model helps in reducing the variance? Reducing variance is bagging. Another one is, which of the following is a true or false about ensemble methods? So 1 and 4 is the true. Remaining these two are false. So which of the following is not example of ensemble method? So ensemble is ADA boost, random forest, boots. These are all ensemble. A decision tree is not an ensemble method. It is a classification technique. Suppose your model is overfitting. Which of the following is not a valid way to try and reduce overfitting? So that is this is your improving optimization algorithm being used for error minimization is not the best choice. So ML algorithm build a model based on sample data, which is called your training data. So when you build a model, you see sample data is nothing but your training data. What is the function of unsupervised learning? Again, find the clustered, low dimensionality representation, novel observations, all the above is the answer. So this is how this one. So let me see how many are. Where is the answer? So let me post the score so that everyone can see your scores. I just posted your score, you can see. The first mark is four people, 4 or 5 people, very good. So Rupeshai Narendra, very good. Chandrakiran, Teja Reddy, BSVN Kumar, Jnaneswar. Oh, very good, very congratulations, guys. So 48 is almost So these type of quizzes will give me an idea. So who is doing well? That is what I am conducting these quizzes. I may not teach one of you. So such quizzes, it will give me an impression or some kind of base idea. So that is what we are doing, all such things. So you take give some little importance to such quizzes, whether you are understanding. So this will give you about your understanding. For you it is understanding. For me it is an impression. That's it. So 48 is Srivardhan, Madhav Reddy, Dishita and Janavi, Chinta Chadurya, Shruti and Lokesh. So 48, very good. 46 is one, two, three, four, five, six, same. 46 also for 6 people. Pranav and Shahansha and Samrisha Chaudhary, Riya Rai, Manvita and Vrinchi. So there are 46. Salma, what is the least score? Let me see. That is very important. So least score itself, it is 26. So 50 percentage above 50 percentage. So quite good. So in between 38, 36, 32. So that is a worst. I mean that is the least mark. Then very good. Only 126. Remaining all good. So very good. So I think you understood the module 1. So let me see. So now we can proceed with module 2. So thank you guys. Thank you. So let me download the attendance. Then you can leave. Yeah, others can leave. Thank you. Yashwant, you wanna say something? Okay.
Sir,
You just raised your hand, no? Just I asked. Dishta, yeah, tell me.
can you please
Can come again?
upload the decision trees problem PPT?
Yeah, yeah. Today I will finish it. I'll upload it now.
Okay, sir. Thank you.
Because I just convert. I am uploading a module-wise PPT, right? So let me upload a complete PPT module 1. I collated all the individual PPT into as a single.
Yes,
So
sir.
you will get only 6 PPTs, module 1 full PPTs, 300 slides. That will be quite good for you also. So let me delete all these things. So you'll get a single PPT so that you will get it.
Sir, that quiz, like last week you have conducted one quiz, right?
Yeah.
So is it graded or ungraded?
For what? Non-cat, huh?
Yes, sir.
No, no, this is just for your understanding. Yeah.
Okay, sir.
So I'll keep you quiz after module 2. I'll keep one quiz. For I think for you non-cat, I told you no only project. Project is a main component. So for a single project will take 15 marks.
Okay,
I
sir.
asked you to identify the titles, no?
Yes, sir. You have said it in last class.
Yeah, yeah, yeah. So only project is considered for your non-cat evaluation. No quiz. Quiz is just for your understanding. At the end of module, I used to conduct a quiz. So that is what, nothing else. I just
So,
uploaded my PPT
so
just to
one
check it
doubt,
out.
like project in the sense we need to do the research paper, right?
After implementation only, no, you can do that.
Like in research paper, if we just keep the algorithm, isn't not enough, sir.
But without implementing algorithm, how do you give the results, experimental results?
Okay, I understand.
Ah. Experimental results is one of the section in the paper. So remaining all other introduction literature survey, all other works you can fill it from anywhere. You can copy paste, you can rewrite whatever maybe. But the experimental section you need to give the results, analysis. Yeah. Writing a paper or not secondary matter, but first you try to finish the work. Once you finish, we will go for the next process.
Yes.
So
Thank you, sir.
that can be research paper work or
Sir?
normal paperwork. Yeah. You just identify the title and let me know. Then I will tell you whether it is a research paper related topic or it's like a normal topic. I will be circulating the Google link so that you can fill it off.
Yes, sir. Sure, sir.
Yeah.
Thank you, sir.
Okay. Thank you all. I uploaded the PPT. I just uploaded a single PPT, module 1 full PPT. Title is module 1 full PPT. So you can download it. So there's a 350 slides, complete module, all first module. Similarly, I will upload for all other ones. Module is over, I will upload it. Okay.
Thank you, sir.
So that you can keep it in mobile and you can study for your, or else you need to open multiple PPTs. Yeah. Thank you, Alma. Thank you. Bye.
Sir,
Yeah.
what is the syllabus for Cat 1, sir?
Cat 1 same, whatever I up to what I covering, no? So in module 2 that will be the topic. Today linear logistic over. Tomorrow class I will teach you someone with an example, coding and the problem. Probably I will cover complete module 2, no issues. Concept wise I will cover linear logistic, polynomial regression and KNN. So 4. You will get 2 questions from first module. Probably you will get 3 questions from module 2. Let's see.
Okay.
Yeah. At the once end of this month, I can suggest you. Yeah.
Okay, thanks.
Don't worry. I will give you all the ideas about CAT exams, how to write all other things. Don't worry. Okay, guys. Bye.